All right, so I want to spend a little bit of time going over in some more detail the synthesis problem that we did in class yesterday. I mentioned that there were several ways to do it, and some of you thought it might be helpful to actually see me work through those ways. So let's look at the problem and see how we can approach this. So one question that a couple of people had, I know, was, we've got this alkylithium compound, and in my synthesis I used that twice. Is that allowed? And so it's always important when you're doing synthesis problems to remember that if you have a compound, you have essentially an infinite amount of that compound. So if you have this 3-carbon component, you can use that component as many times as you want. Because the way to think about it is that you have some reagent bottle on your bench filled with that compound, and you can just use it over and over again. All right. So one way to think about this is to number this compound, 1, 2, 3, and see if you can find those 3-carbon units in the product, right? And I hope that it's reasonably clear that we have 2 of those isopropyl units in the product, all right? So when I'm looking at this problem, I'm seeing, all right, I'm probably going to end up using that compound twice in my synthesis, all right? And then recognize that I have 2 other 1-carbon pieces that I need to bring in, carbon 4 and carbon 5. And so I should think about, how do I bring in 1-carbon pieces, whether that be carbon dioxide, formaldehyde, something along those lines. So have that sort of rolling around in my head. All right. And we have to think backwards on this problem at least one step. And we talked about this in class, which is the question, how do I make an imine? Right. And an imine can only be made in one way. At least we only know one way to make the imine, right? And that's from a ketone plus a primary amine, right? So that's a really important disconnection, is to make that decision. And in this carbon, again, is carbon 5, right? So there's one of our 1-carbon pieces. All right, so now we have to think about, how do we connect the alkylithium over to that ketone, right? And there was one way that we did this in class, right? And the way in class was to say, all right, I know that we can break this bond going backwards, because if we have a carboxylate anion and we add an alkylithium to that, we know that's going to end up making a ketone. Right, that was one of those mechanisms with some steps that were a little bit strange, where it went through a hydrate and then it collapsed to a ketone. And then hopefully when you see this carboxylate anion, you remember that you can make that by reaction with carbon dioxide, and there's carbon number 4. Okay, so that's, I think, a really nice way to think about this, if you remember this step where you have the carboxylate anion plus the alkylithium, right? And maybe you don't remember that, and that's okay, right? Because again, the question is, well, how do we make a ketone? And hopefully one of the most straightforward ways to make a ketone is to think about oxidizing a secondary alcohol, right? So we could think about that as coming from oxidation. And again, we'd use PCC or chromic acid, one of our 2 oxidants for that, wouldn't matter which one. And then we get here, and the question is, how do I make a secondary alcohol? And we're very good at making secondary alcohols, right? So we could imagine break off one of those bonds, and that could come from an aldehyde plus our 3-carbon alkylithium component, right? That would work fine. And then how do we make an aldehyde? Well, we make an aldehyde from a primary alcohol. How do we make a primary alcohol? That's where we can do another carbon-carbon bond disconnection, alkylithium plus formaldehyde, and again, there's carbon 4. So we have our 1-carbon pieces. Okay, So anyway, I think those are two really nice disconnections. I'll go through the forward synthesis of those just so you can see how they look. All right, so we'll do the synthesis. All right, so we'll have two options. So if we started with alkylithium plus CO2, we can make a carboxylic acid. Right, and then we could do our reaction with two equivalents of alkylithium. First equivalent removes the proton, second equivalent adds to the carboxylate anion. And again, remember, this is the one step where we have to use the alkylithium instead of the Grignard reagent. Grignard reagent won't add to the carboxylate anion. And then acid, so that we get the hydrate, and then the hydrate collapses to the ketone. Right, so we get to the ketone, and now we have to form the imine. And we can form the imine by adding methylamine. We'll have catalytic HCl, and it's very important to note that we have to remove water, because again, this is one of our equilibrium reactions. If we don't remove water, we won't get a good yield of the product. All right, so we have a 1, 2, 3-step synthesis of the molecule that we want. All right, then we can do option number 2. Alkylithium react with formaldehyde and acid. That gives us a primary alcohol, PCC. Gives us an aldehyde. Add the alkylithium again. Get to the secondary alcohol, and I'm just going to cheat a little bit and go to the compound we've already made up here. Right? And again, here you can use PCC or chromic acid. Either one will be fine. And then you do that same step we did in the previous synthesis. So here you have a 1, 2, 3, 4, 5-step synthesis. A little bit longer, but that's fine. Not a big deal. And one thing that I want to note, I know that a couple people were thinking about, oh, we can do this by doing a reaction with an acid chloride or an ester or something like that. You have problems when you're thinking about doing this reaction with an ester because you don't have enough carbons to play with. But one interesting synthesis that I think is worth mentioning is the following. All right, so let's call this option number 3. All right, so the question is, what happens if we have two equivalents of alkylithium plus this really interesting diacid chloride? Right, and so the thought was that we could add 2 times to this, and that would give us a very nice and quick synthesis of that ketone. All right, so you could imagine doing a substitution reaction once, tetrahedral intermediate, reform the carbonyl, get an acid chloride, tetrahedral intermediate again. And so if that's not clear, make sure you write out the mechanism for that. And my guess is that you would get some of this. But the problem that you run into in this synthesis is that you'll end up with ketone in the same flask as the alkylithium. I understand that if we're trying to get the ratios of these right, you know, that we will get some of that, but you'll also make some initially and you'll still have some alkylithium left. So I think that you'll get a mixture of the ketone that you want plus some of that tertiary alcohol plus some of the unreacted diacid chloride starting material. So this is a really nice idea, but it's not as clean as these other ones in terms of giving you only one product. You'll get a mixture of products. And then clearly you can take this on and form the imine that you want. But what I would say is that this is a good answer, but these options 1 and 2 are better answers. But again, a really nice idea as a way to make this compound. So anyway, I hope this is useful. in thinking about the synthesis problem we did last time. And again, please let me know if you have any questions about what we've done here.